Hello everyone. This is our set of the day. It says a boat racing competition was held at the Hussain Sagar Lake in Hyderabad, in which total 10 boats participated. Two ends of the lake, they are tagged as A and B as the start and the reverse. The boats start from A and they go to the other end B, and then they row back to the end A without stopping at the B. That's why B is the reverse end. All the 10 boats started from A at the same time, and some data is known to us. The distance between the two ends is 2 kilometers. Speed of all the 10 boats were different from each other, but the speed of each boat remains constant. The distance from the end A at which the two boats are present at the time is called the meeting point. That simply means that if, let's say, this is A and B, and at some point C, two boats are meeting, the distance from this end A, right, this is called the meeting point, where two boats will meet at least, right, at which two boats are present at a time. That is called the meeting point. So first question says, find the number of meetings for all the boats taken together at the meeting point during the race. Now it is given to us that speed of all the boats is different. Speed of all the boats is different. If the speed of all the boats is different, question is asking for the total number of meetings, right? So this is point A, this is point B. Obviously the fastest boat will reach B first and it will come back, right? Let's say fastest boat is X1, then X2 second fastest, X3 third fastest, and so on up to X10. So when X1 reaches at this point, obviously X2, X3 all are behind it. They are having the different speeds. So when X1 comes back, it will meet X2 at some point. It will meet X3 at some point, X4 at some point, X5 at some point, X6 at some point, and so on. That means it will meet all the 9 boats at some points. So total meeting points for the fastest one are 9. X1 have 9 meeting points. Similarly for X2, X2 already has met with the X1. Now when X2 reaches at this point, it will meet X3 at some point, it will meet X4 at some point, X5 at some point, and so on up to X10 at some point. Since it already had met with X1, so it has now left with 8 boats to meet. Similarly, when X3 comes back, it already met with X2 and X1 on its during its onward journey to B. So when it will come back to from B, then at some point X3 will be meeting with X4. At some point it will be meeting with X5, because X3 has reached the point B. Now it's coming back. X4 is just going towards the B, right? So it will meet X6, X7, and so on at some points. It has 7 meeting points. Similarly, on the same lines, X4 will have 6 meeting points. On the same logic, X5 has 5 meetings, because all the meetings with the X4, X3, X2, X14, X5, they are already counted, right? X4 has left only 4 meetings, X5, X6. X7 has left with only 3 meetings, X8 is left with 2 meetings, X9 with 1 meeting, and X10 has met with all the boats. So total meetings would be 1 plus 2 plus 3 up to 9. If you add up all these, it will be 45. Next it says, find the minimum possible number of meeting points in the lake. Minimum possible number of meeting points. Now to get the minimum possible of number of meeting points, we already know that X is meeting with, if let's say boats are X1, boat X1 has speed X1, boat X2 has speed X2, boat X3 has speed X3, and so on. Boat X10 has speed X10, right? So we know that the fastest moving boat X1, it meets with all the other boats at 9 points. It meets with all the other boats at 9 points. So 9 minimum possible points are definitely there. Now let's see. that are they actually 9 or they will increase. Let us say x1 and x2, they are meeting at this point, say C, right? And this is this has a distance a from point A. So when x1 and x2 are meeting at this point, let's say x1 and x2, they are meeting at this point, then the time taken by both x1 to reach C is equal to time taken by x2 to reach C. Both times will be same. Time taken by x1 to reach C, it will go to B, then come back to C. Whereas the second boat x2, which has speed x2. Now remember, these are the boats as well, the speeds of the boats. x1 has speed x1, x2 has speed x2, x3 has speed x3, and I am considering x1 to be fastest. So since they are started from at the same time, so the time taken by x1 to reach C will be the time taken by it to reach B and back to C, and the time taken by x2 is simply the time from A to C, and they are equal, they should be equal. Now time is distance over speed. Now how much distance x1 has traveled? x1 has traveled 2 kilometers from A to B, and if this distance AC is A, this will be 2 minus A. It has covered 2 kilometers from A to B, and 2 minus A distance from B to C, divided by speed is x1, and for this boat x2, it has just covered A kilometer and its speed is x2. Now from here I get this relation x1 by x2 is equal to 4 minus A upon A. Okay. Now let us now assume that since we need the minimum possible number of meeting points, so let us now assume that after meeting x2 with x1, let us assume x2 went to point B, x2 came back, and x2 met x3 at the same point. Since the meeting point should be minimum, that's why I'm taking this. I'm considering that, let me repeat once again, that x1 and x2, they met here for the first time. After that, x1 will move its journey, keep on moving its towards A. It will continue its journey towards A. So x1 will be moving in this direction. x2 will go to B. After touching B, x2 will come back, and x2 again meets the third boat x3 at the same point C. x2 and x3, they are again meeting at point C. Now when that happens, again in this case x2 has traveled 2 kilometers up to B and back 2 minus A, so it has covered 4 minus A at the rate of x2, and x3 boat, which is again meeting with x2 at the same point, it has covered only A kilometers, divided by speed is x3. Now this will give me x2 upon x3 is equal to 4 minus A upon A. Now these two equations tells that the ratios are equal. Ratios of the speeds are equal for the consecutive boats, right? For x1, x2, they are the consecutive boats. In terms of speed, their ratio is equal to the next consecutive boats. Similarly, we can prove that x3 and x4, they have the same ratio. x4, x5, they have the same ratio. So all these boats are meeting at the same point C. So two consecutive boats, the two boats with the consecutive speeds, I'm not saying x1 and x3 will meet at C. I'm saying x1 and x2, the two boats with the consecutive speeds, the two consecutive fastest boats, the fastest and the second fastest, they will meet at C. The second fastest and the third fastest, they will meet at C. The third fastest and fourth fastest, they will meet at C. The fourth fastest and fifth fastest, they will meet at C. Right? So all these boats will meet at C only. Okay. So since all the boats are meeting at C, That means C is one of the points. Further, there are 9 points because x1 is meeting x2 at C, so it cannot meet x3 at C because x1 is already towards its journey towards A. So अगर x1 x2 यहाँ मिलते हैं तो x1 x3 यहाँ नहीं मिलेंगे. x1 x3 will meet at some other point. x1 x4 will meet at some other point. That means in total we have 9 points at least for x1 to meet with every other board, and the minimum number of meeting points in this case would be 9. So I am assuming that all the boards x1 and x2, x1 x2 x1 x3 and so on, they are meeting at the point C. x1 x2 they are meeting at point C, x2 x3 they are meeting at point C, x3 x4 they are meeting at the point C, x4 x5 they are meeting at point C, and so on. Right, so at least 9 meeting points are there. Now you can ask me next part, that what about x1 and x3, what about x2 and x4, what will happen for them? The logic is same. One thing is very much clear, that let me erase this now. One thing is clear, that 9 points would be there on this line. There would be 9 points where the meetings will take place, because here is the point where x1 and x2 will meet. At this point x1 and x3 will meet. At this point x1 and x4 will meet. At this point x1 and x5 will meet. At this point x1 and x6 will meet. x1 and x7, x1 and x8, x1 and x9, and x1 and x10. Right, so these are 9 points, and we proved that it is very much possible that since x1 x2 they are meeting at this point, so x2 x3, the next two boards with the consecutive speeds, they will also meet at this point. x3 x4 will also meet at this point, and so on. x9 x10, which have the two consecutive speeds, they will meet at this point. Now with the same logic you can also prove that if x1 x3 are meeting at this point, then x2 x4, the two boards with difference of speed 1 or one board between them, they will meet at this point. x1 x3 are meeting at this point, so there is possibility that x2 x4 can also meet at this point. For that, the logic is again the same, that distance up to this point is, let's say, b, this distance is 2 minus b, the same logic which we discussed in the previous one. So basically the ratio should be, in this case, in the first case, the ratio of x1 x2 was same with x2 x3. Now in this case the ratio of x1 x3 will be same with x3 with x2 x4 and so on. Next will be x3 x5 and so on. Right, so their ratios will be same. It's just like this, that the slowest one has a speed 1, second slowest has a speed 2, third slowest has 4, then 8, then 16, then 32, then 64, and then 128, and so on. Now you can check that these two have the same ratios. If you take the consecutive boards, they have the same ratios, so they can meet at the same point. Similarly, if you take the boards with one board skipping, so these two have the same ratio as these two boards. Similarly, these two boards or these two boards, they have the same ratios, so they can be meeting at the same point here with one board skipping. For x1 x4 the gap is of 3, so it could be next, it could be x2 x5 which are meeting at this point, x3 x6 could be meeting at this point, and so on. The last one will be x7 and x10. So basically if I continue this one, this can be, last will be x8 and x10, right? So that is very much possible. We can superimpose the meeting points of the other boards on these 9 points. So answer to this very question is 9, that there would be 9 meeting points only on the minimum side. I am not erasing this. No, let's say first of all do this question. It says suppose the meeting point of the board having the highest speed with the boards having the second highest speed, third highest, and fourth highest are numbered as a first, second, third, ninth respectively, right? So this is the first meeting point, this is the second, this is the third, right? Meeting point of the highest with the second highest is numbered as 1, with the third highest is numbered as 2, fourth highest is numbered as 3, and so on. This is the 1, this is 2, this is 3, and so on. If the meeting points in the lake were minimum possible, which is 9, then at which meeting point there will be exactly 5 meetings. Now you can check that at the first meeting point, there are 9 meetings basically between x1, x2, x2, x3, x3, x4, and x9, x10 up to x9, x10. So there are 9 meetings at this point. So at the first meeting point, there are 9 meetings. In the second meeting point, the meetings are of x1, x3, x2, x4, and so on up to x8, x10. At the second meeting point, there are 8 meetings. Similarly, at the third meeting point, it is between x1, x4, x2, x5, x3, x6, and x7, x10. So at the third, there are 7 meeting points. Similarly, at the fourth meeting point, there will be 6 meetings. At the fifth meeting point, there will be 5 meetings. The question says, at which meeting point there will be exactly 5 meetings? Answer would be answer option 1. At the fifth meeting point, there will be 5 meetings. So I'm just superimposing the meeting points of all the other boards with the 9 meeting points of the fastest one. That can happen, and we just seen that by taking the ratios. If you just take the ratio, let's say 2, 1, 2, 4, 8, 16, that can happen. Now, in this question, it says that if the meeting points in the lake were minimum possible, again 9, and the speed of the fastest and the second fastest boat is 10 and 8 km respectively, find the speed of the fourth highest boat having fourth highest speed. Now, if the meeting points are minimum possible, then we know that the ratio of x1 and x2, the fastest and the second fastest, is same as the second fastest and the third fastest, equal to the third fastest and fourth fastest. We prove that just right here. And then x4 and x5 and so on, right? So ratios would be same. Ratios of the consecutive boats with the consecutive speeds, that will be consecutive fastest speeds, that will be same. Now here the first and second boats, they have the ratio as 10:8, means 5:4. So that means the ratio of the second and third will also be 5:4. So if its speed is 8, it's x, so that means x over 8 is equal to 4 by 5. X is nothing but it is 4 by 5 into 8, right? So this will be around, if I solve 32 by 5, so it will be 6.4. So third speed is 6.4, right? Similarly, fourth will be 6.4 into, here we did 8 into 4 by 5, right? So it will be 6.4 into 4 by 5. So that comes out to be 5.12 kilometer per hour. So the speed of the fourth highest, speed of the boat having the fourth highest speed is 5.12 kilometer per hour. So this was all about this set. This question we already discussed.